What's up guys? Today we're going to be learning how to solve a system of equations by graphing. So to do this you just have to be familiar with the slope-intercept form of a line and how to graph a line that's in that form. Alright, here it is. Alright guys. So nowadays with so many graphing calculators and websites that'll graph lines for you, you're really only ever going to use this method to solve a system of equations if you're specifically being tested on it. And again, a system of equations just means multiple equations happening at the same time. And we are starting with linear equations, so these are both the equations of lines. And to solve by graphing, we're simply going to graph both of these lines, and we're going to see where they intersect. We're going to see where they cross, if at all. And then that point where they cross will be called the solution of the system. And so these lines are both in slope-intercept form, right? Y equals mx plus b, where m is the slope, the coefficient of x is your slope, and b is your y-intercept. And so, of course, I can substitute values in for x and see what y is, and then just graph all the points that way, but that takes a long time, and it's a lot more work than necessary. So, knowing that this is slope-intercept form, we can just go ahead and identify our y-intercept, right? The b value, which in this case is positive 6. So I'll go ahead and graph a y-intercept of 6 here. 1, 2, 3, 4, 5, 6. And then I know the slope is going to be the coefficient of x, and the coefficient of x in this case is just 1, right? This is just a 1x. And so remember, slope is change in y over change in x, also known as rise over run to some of us. And since the slope is just 1, well, 1 as a fraction is 1 over 1. And so from my y-intercept, I'm just going to go up 1 and over 1. And so I can keep plotting points this way, knowing that my slope is 1. I know that for every increase in one x value, I'm going to increase by one y value. And the reason I'm plotting so many points here is because we're going to be looking for an intersection point. So I don't know quite where that is yet, but I want to make sure I know where this line is exactly. Now, don't be like me and freehand your line. I would strongly recommend using an actual ruler or a straight edge of some sort. So now that the first line is graphed, I'm going to go ahead and graph my second line. So I'm going to look for my y-intercept. I know that the y-intercept is -4. So I'm going to go ahead and plot a y-intercept of -4. And now remember, slope is the coefficient of x, which in this case is -3/2. And knowing that the slope is change in y over change in x, that means I'm going to be changing -3 y values for every positive 2 x values. So in other words, I'm going to be going down 3 for every 2 that I increase in the x direction. Right, down 3 for every 2. And then that goes both ways, right? So instead of going down 3, I can go up 3 and left 2. Right, so I can extend the line up to the left as well. And it looks like here is where we're going to find the intersection, because I'm going to go up 1, 2, 3, and left 2. And that's where they're going to end up crossing, right? And so this point right here, that's going to be 1, 2, 3, 4, -4, comma 2, right? -4, 2 is the solution to the system. So what that means is that this is the only point, -4, comma 2 is the only point that will satisfy both of these equations. So in other words, if I substitute -4 in for x up here, I get -4 plus 6, and that gives me 2. Okay? And the same thing will happen here. If I substitute -4 in for x here, and I do the math, the y value will boil down to 2. And this is the only point that will satisfy both of them. Okay? So there's some ways you can get thrown a curveball here. And one of those ways is if your line isn't in slope-intercept form. So of course you can graph a line from a variety of different forms, standard form, point-slope form, but within the context of solving systems of equations, I think it's probably easiest just to get everything to slope-intercept form. So since this is already in slope-intercept form, I'll go ahead and graph this one. So that's going to be a y-intercept of +4. And then I have a slope of -1/2. So that's going to be down 1 over 2. Okay, and I'm going to do this in both directions, so I'll go up 1 and left 2. And again, you should probably use a ruler for these. Alright, so now that we have the first line graphed, I want to go ahead and get this one into slope-intercept form. So remember, that looks like this, which basically just means I need to solve this for y. I need to get y by itself. And so to do that, the first thing I'll do is I'll add the x term over. So I'm going to add 4x to both sides so that I can cancel these x's. And so I'll be left with 2y equals 4x, +4x, minus 2. And then, again, the goal is to get y by itself here, so I'll divide both sides by 2. And remember, you have to divide the entire side by 2. You can't just pick and choose which term you want to divide by 2. And so I'm left with y equals 4x divided by 2 is 2x. And then -2 divided by 2 is -1. And so now I'm in slope-intercept form. And the reason why slope-intercept form is useful, of course, is because it readily tells us what the slope and y-intercept are. So y-intercept is -1. And now my slope is 2. And 2 is a fraction, is 2 over 1. So my change in y is going to be 2, my change in x is going to be 1. So my change in y is 2, my change in x is 1. Okay, and then I can do that over and over and over again. It looks like that is where we'll be crossing. Okay, so this is 2, 3. So the solution to this system of equations, the one single point that will satisfy both of these equations, is 2, 3. Now there are some special cases where you might not get any solution, or you might actually get infinitely many solutions, but I'll save that for another video. So with that said, guys, it's been demonstrated.